This is more for you, Michael. I couldn't, you presented a very dense amount of information. It's really intriguing. I couldn't digest all of it as it was going by. One thing I was looking for was how far back you are going in your models, basically to take the models you developed and go back in time. And as best I saw, I think I saw you go back to 1970. Have you used your models to go back a lot further? And if you have not done so, what would incline you or disincline you to do so? Like back to 1900, for example, include both world wars and things like that.
Let's see, does this work? Yeah, good. I presume you're talking about the empirical model, which is the one that I presented first, because the other one is just basically a scenario that you could start off at any time, right? Which, in fact, what I didn't mention during the talk is that what I had on the horizontal axis was time, and it was tau plus a certain number of years. And it wasn't, I left it unspecified what tau was. It could have been any point either now or 5 years or 10 years from now, depending on which view you take about when peak oil or some sort of supply reduction might happen. I just wanted to clarify that this is only partly related to your question. As far as the empirical model is concerned,
I was wondering about your model you developed.
do you mean the theoretical model?
Theoretical model, but you could apply that as far further back to.
It's not really clear what that means, right? I mean, basically, the way a theoretical model works is you just basically devise a theoretical structure that you think best explains how economies work and interact. And this is a model of the world economy, of the entire world economy. And then what you do is you calibrate that model, meaning you assign values to parameters that determine things like the investment share in GDP, the labor share in GDP, the government spending share in GDP, and various elasticities and things like that. And the way we do that at the IMF is we get the very latest data on what those ratios are around the world, and then we put those into the model. And then we can run simulations saying, okay, let's say the economy is in some resting state in 2011, and let's go forward from there, or at some point tau, as I had in that particular kind of, simulation. If you're telling me, what if I had started that whole thing at 1970, well, what I would have to do is to look at the parameters that characterize the world economy in 1970. The ratios would have been different, maybe some elasticities would have been. It's very hard. I mean, I don't think it would have been quantitatively a little bit different, but qualitatively not very much, because the world economy hasn't changed that dramatically. I think in terms of its basic structure, right? So I think that's the best I can answer.
Thank you for the presentations. The price of oil is, of course, the tricky thing, and there's one inequality in the world that you must take into consideration, and that is that there are exporting countries and importing countries, and the price of oil for Europe, for instance, it cannot be too much before the economy crash completely. And you are talking about, I've had a thought many years back that his price could increase, but then I heard the CEO of Airbus that he was asked in 2008 when the price was increasing, what do you think about the future price? And he said, well, I can tell you, if the price ever reached $200 per barrel, there will not exist an airline industry, period. And if there don't exist an airline industry, period, then the global economy is over. So it's these kind of equalities, must be into the model. Otherwise, it's worth nothing.
What? That was directed to me, was it?
Yeah.
Yeah. I completely agree with you, and this is precisely the kind of thing that I need to understand, right? I also think if the oil price was to go above 200, there would be very serious short-term problems. The question is, would they last forever? For example, is it possible to think of a scenario where the oil prices would have to gradually rise past 200, and the airlines would just pass that cost on to their customer? So while there would be a lot of short-term pain, there would still be an airline industry with very high ticket prices 20 years from now, or not, and if not, why not? This is precisely the kind of thing that I need to understand, in order to model this more accurately. In this model, it's continuous, it's smooth. You know, as the oil price rises, there's a certain elasticity of substitution whereby you can substitute to other things, like from air transport to, you know, traveling by boat or something, but it is not like, there's no dramatic trigger point at which something qualitatively changes.
Another very small thing is that the fact that your model is probably working if the oil was distributed equally among the countries in the world. I mean, United States is an exception. They can borrow money.
People can't hear you. Wait.
United States is an exception compared to other countries in the world. You can borrow money from all over, and you can spend them without having to pay them back in principle, you know. But Greek cannot do that, and Italy cannot do that, and Sweden cannot do that. And your model, I mean, this equality distribution of oil in the world must also be part of that.
No, but that is part of the model. I mean, that's there. I mean, basically, we do have certain budgetary abilities of countries to handle this. What is explicitly part of the model is that there's countries, the oil exporters have oil funds that they accumulate when the oil price goes very high, and the way in which this oil fund is then invested in other countries in the world depends on the ability of other countries to absorb that high oil price. We have also calibrated that certain countries have a low or a high ratio of oil use relative to their overall output, etc. A lot of that, probably not in the detail that you would like to see, but a lot of that is already in the model. Okay, so that's on the point. I think your first point about these trigger points, that's really what I like to get a handle on.
Could I just make a comment on that as well? So I think these are obviously, they're all dynamic variables. Everything's a moving part. The problem is whenever you give any kind of presentation, certainly the one I was giving, Michael's model is trying to normalize for all these variables. But you know, you're isolating one variable at a time and assuming the rest of it is static. And the reality is everything moves in real time, and I think what is being said now about $200 a barrel will be the death of Europe and so on, I mean, first of all, Europe's doing a pretty good job of killing itself already at current prices, and secondly, the airline industry is already in chronic trouble at current prices, but that doesn't mean prices can't go higher. I mean, this is how the market economy reallocates resources, you know, and I think it's equally unrealistic at the IEA to assume that, you know, demand in the Middle East is going to be much lower than might realistically be expected, and that therefore the price is going to be $120 a barrel in 2020 in 2011 terms.
So I have, thank you for the comment, you know, talking about economists as you know, shopkeepers of the society. But at the same time, economists hold an enormous sway on the society, which cannot be said of us, the scientists. So therefore, your language from, you know, many vintages is far more important than the language of science or engineering. But having said that, I, as a scientist, know that the world is described by partial differential equations, and I use them in 3D plus time. And so, therefore, economics has to be described by some multidimensional partial differential equations. These equations, then, once they are admitted, do admit discontinuous solutions. And so, therefore, they, for example, you know, admit readily the existence of shocks, right? So, the weak solutions. And so my question to you, and I don't expect you to give me an exact answer, but how, and that betrays my lack of knowledge of economics as it is practiced today, how ready are the economists to deal you know, with partial differential equations in describing the world, and therefore creating these shocks that Shell is talking about, the discontinuities that must emerge if certain thresholds are exceeded, and certainly things that are ahead of a phenomenon are slower than things that follow, and therefore you create a shock of sorts. And so that's my question, you know, because with the, you know, with the power laws or the formulae that you have on the screen, you can't do that. And they're just continuous reallocation of everything.
So what is in the model is, of course, not just what I put up there, that one equation, which was the production function, but there's a set of dynamic equations. In fact, there are thousands, literally thousands of equations, of dynamic equations. They are not partial differential equations, they are difference equations. But there is, you can represent, we would have severe difficulties doing that in this. I mean, first of all, these models are written in discrete and not in continuous time, and so that's a consideration. But there are always ways to map into to map reality into mathematical equations in different ways. And you could, in this model, for example, introduce some highly nonlinear features, some kinks, that would capture the same thing or something similar to partial differential equations. You just need to be a little creative, and what you need to do is you need to first of all have reality in your mind and not some sort of way out there academic world that has nothing to do with reality. And then you need to think about how can I creatively map that into the structure that I know how to work with, which unfortunately is not partial differential equations, it's difference equations, but I can still do a lot in that world. And for example, what I did there with entropy, I thought was something, at least it was an attempt, and I would like to get some feedback on what people think about that and whether they can think of better ways of doing the same thing. Because I cannot overnight change my language, partly because I cannot communicate with the economists that you say, and you rightly say, are so important to be communicating with. I can only communicate with them in this language and try to get as creative as I possibly can and as connected to the real world as I possibly can. And so I need you to give me feedback, not in the sense of saying, oh, you need to use partial differential equations, but how you need to change your framework in certain ways to get closer to reality. And I'll be totally enthusiastic about that.
Mark and Michael both, I wonder if you might briefly talk about China and India. What if scenario? What if their consumption keeps increasing at anything like current rates out for 5 to 10 years? Mark?
Well, I don't do the kind of detailed economic modelling that Michael does for a living, but if their demand keeps rising at the rate it's been rising, and we have these supply pressures that we've been talking about, then I think it's very clear that is going to continue to put upward pressure on oil prices. I mean, I think there's one other area that we didn't get into here. That there's a lot of scope for more energy efficiency. Okay, and that is going to be a key variable, I think, on the demand side going forward. But it's going to have to come in the countries that are oil importers rather than the exporters. There's no pressure on consumers in the OPEC countries and in the major exporting countries to become more efficient in their use of oil the way there is for people who are exposed to the real international price. But there are some enormous differences between the levels of efficiency even between the major OECD countries, which as a European, I'm always struck by when I come to the United States, just in terms of the size of the cars that are driven and the way that energy is consumed in the US compared with Europe is very strikingly different on all sorts of levels. So I think that's something that is going to have to continue to be worked upon, but I think the good news is there is a lot that can be done in terms of becoming smarter in our use of energy. But clearly, these trends, these countries, such as China and India, that have racked up large current account surpluses with their exports. They've got lots of dollars. It's easier for them to pay for this oil than it is for Europeans who today, with the devaluation of the depreciation of the euro against the dollar, in Europe today, we're paying the same price for oil that we did in 2008 because the euro has depreciated against the dollar so much. So these are really, it's just going to continue, I think, to reallocate wealth around the world and put more and more pressure on consumers to change their consumption patterns.
I don't have any special expertise on that question, except to say the rate at which India and China are going to grow their oil consumption is endogenous. So to say that for some exogenous reasons they're going to grow it at some rate I have trouble thinking of the world that way, because what's going to happen to them is endogenous to what happens to everybody else, and that's how our model works.
Ron, Swenson, expression.
speaking of India, there's a saying in India that everything works out for the best in the end. If it isn't working out better yet, it's not over yet. So my question to either of you is that if, in fact, this is an end game and all of these countries around the world are in a race to the bottom of the barrel, are there any countries, either in OPEC or outside, that are either seriously in the pathway to get off of oil and to go towards a different kind of economy, or that are even talking about such things?
Yeah, I mean, I could say a few words on that. Certainly in Saudi Arabia, in the UAE, they are very conscious. On one level, they're very conscious that the model of consumption they have at the moment is, if not unsustainable in the short term, then at least very harmful to their export revenues. They could be earning a lot more money from exports if they were consuming less at home. So there is a particular emphasis in these countries. There's a lot of academic work being done in these countries on how they can change the structure of the power generation industry and move from oil, a 60% dependence on oil for electricity generation, to either more gas and or nuclear and solar. And solar, of course, there are very few places in the world that are intrinsically better than Saudi Arabia to do solar power. I think the problem is that the potential is there, and if the political will is there as well, that can make a difference over time. But it's very difficult to see how that can make a meaningful difference in the short run to 2020, given, as I said, that they're already in the process of building 6,000 to 7,000 megawatts of new oil-fired generating capacity, and that there is always this short-term institutional inertia in the system that means the system carries on the way it's been going on because that's the easiest thing for everybody to do. And as long as the oil price keeps going up, I mean, this is the paradox. In a way, that the implicit subsidies get higher and higher every year as the oil price goes up. But because the price is going up, people think, well, this is okay. We can still afford this. So it's what's going to be the catalyst for them to really change the model. That's more difficult. So I think it takes time. They're conscious of it, but taking the action is more difficult.
I think we've got a question up here.
Okay, I read your paper when it came out. It was fantastic, thank you. So the question I have goes along this. Do you not think it's more useful to model the relationship between oil price scenarios and GDP growth? Regular gasoline at $6 in 2015, for example, would shave 2% of U.S. GDP and send the U.S. economy into recession, lowering demand and reducing price. I believe the IMF put it this way: real-world response mechanisms to such extreme increases in oil prices could, in principle, take on two possible forms. One is a much more urgent search for alternatives to oil, reflected in much higher elasticities of substitution. But that cannot happen because, in my view, there are no economic substitutes for oil. Instead, the second form will occur. The other is a much sharper contraction in aggregate demand. The model in its current form is unable to deliver this. If output were to contract far more sharply at the simulated oil prices, the resulting demand destruction would in turn limit the required increase in oil prices. Instead of modeling substitution, could you model supply shocks and conservation, not substitution as a demand response, via a cycle of events that occur while supplies decline at a steady rate, say 2 to 5% per annum? The process goes like this: supply shock, price rise, recession, demand destruction, price decline, conservation, recovery, etc. Is there any way to model that? That's my question.
Well, that's the same question I posed at the end of my talk. So we're on the same page. But I have no further answer in addition to what I said. I'm searching, okay? Okay, good.
David Murphy, you may not satisfy all your requirements, but David Murphy has made such a model. And if you want to talk to me, I'll tell you about how to get it. But just do a search for David Murphy and, I don't know, some of those keywords. Sure. But if you can't find that, I'm Charlie Hall, and I'll give you the references. Sorry.
I thought both your presentations were right on. They were very enjoyable. So I think you both pointed out two important things. So substitutability of alternatives and then the demographics. You put those two things together and that sort of hones in on the challenge, I think, in general. Perhaps specifically for Michael, but also for Mark. You show world GDP, and you imply you have the model breaks down country by country, different kinds of elasticities and income distributions. For a growing world GDP, what does it look like for OECD versus others, right? How many of your scenarios show the United States and Europe not growing, but the world grows as a whole? How do we understand that kind of concept, right? What if the world grows in total GDP, but say Europe and the US do not, right? Can you sort of break that out in your model? Or have you thought about how to at least present information in that way?
What the model assumes is that there's a common growth rate for the world economy, let's say, I forgot what it was in this case, 2 or 3% real. And then you have basically when the shock hits, then some countries are going to contract relative to that trend. So when you look at the charts in that paper, this is always relative to a trend where they're all growing, right? And some others less. And it's not that we have a model where every single country is represented. We have about 6 regions of the world economy, so we don't break out every single country. That's always there. Countries that are always there are Japan and the United States. So there are differential responses, yes, if that's what you were asking. I mean, did I understand your question correct?
Mark, in regards to Saudi Arabia, your numbers are right on the problem. Take a quick look at 7% demand growth for oil. That's what it's been over the last 10 years. Extrapolate that 20 years, and you're at 11 to 12 million barrels a day, which is their current capacity, including their NGLs. There's very little discussion in the Saudi U.S. news reports that I get that even address the subject of taking away subsidies. Why don't they want to talk about taking away subsidies? It's part of their benevolent giving that keeps the Kingdom of Saudi Arabia in power. And we're faced with a very sudden change, probably in the very near future, in the Kingdom of Saudi Arabia in who owns and who controls Saudi Arabia. So I think your point's well taken. Thank you.
Yeah, thank you very much. I mean, we didn't get into I certainly didn't have time, and I'm not expert enough to get into the politics of Saudi Arabia, but clearly that is something that is not at all well understood in the West, and that adds an extra layer of risk onto everything that we've been discussing here.
Might add, is this on?
Yeah.
Lou was the chief petroleum engineer for Saudi Aramco a couple of decades ago. So if you want an inside account from Saudi Arabia, he's in the back room there. And Mark, I wonder if you might, you've talked about net exports to various institutions around the world. I wonder if you might describe the response you get when you bring up the topic.
Sure, yeah, so I published a report earlier this year which looked at similar trends to the ones I've been discussing here this afternoon, and so a large part of my job is going out on the road once you've published a report to meet major institutional investors and some of the large corporate companies that invest in energy markets. And I must say I have been very struck by the fact that even amongst some of the largest institutional investors there is a very low degree of awareness of this problem, as Lou was suggesting. It's just not something that is discussed in the mainstream. It's something that people can understand very quickly once you lay it out to them, and something that very clearly makes most people that I've broached this subject with who were not previously familiar with it sit up and take notice very, very quickly. So I think it is a subject whose time has come, and that we are probably going to be hearing a lot more about this in the future. But it's it's shocking to me that this is not more widely discussed, even in news sources that are more specialized in these kinds of areas. There's very little discussion of it.
Right, Shell has one real quick.
Another company, the other big exporter of oil is Russia.
Yeah.
And in their report, they're saying that the Russian production will go down with 2.5, maybe 3 million barrels. And that is not commented at all in the news and so on. And you see the price, I was kind of shocked that Russia need that kind of price. So what will happen in Russia and Europe and that part also?
Well, yeah, I mean, it's a good question. I wish I had the answer. I mean, all you can try and do is point to the pressures and point to the problems. And I think with the exception of US shale oil, I think that's another reason that it's getting so much attention from people, obviously in the US, but it's getting a huge amount of attention in Europe as well. I hear this all the time from European investors, oh, shale oil in the US, this is going to make a big difference. It's one of the very, very few bits of good news that we've had in the oil market over the last 5 or 6 years. So it's understandable that people want to talk about it, because almost everywhere else you look, the pressure points are reaching, we're really hitting these pressure points.
You noted at one point that you were surprised what the consumption patterns were here in the United States when compared to Europe. How much do you attribute the consumption patterns in terms with oil, particularly with respect to oil, to the EU's 2020 by 2020 plan and its gas tax?
Right. Well, the tax is hugely important. So the numbers are very roughly, every citizen in the European Union consumes about 10 barrels of oil per capita per year. And in the US, that number is about 22. And in Canada, it's 24, and in Australia. So Australia, Canada, the US are all very similar, and they're similar in other ways. They're very big countries. They have lower population density than Europe, less public transportation, probably less extreme temperature variations. Certainly that's true in Canada. So there are lots of historical, structural reasons why these patterns are different, and the pattern of economic development over many decades has had a big role to play in that. But I think the tax issue is a very important one. In Europe, every gallon of petrol or gasoline that we pay for, 2/3 of the price goes to the government. 2/3 of the price is tax, and in the US it's about 15% on average. So that does make a huge difference. And again, it shows you when there is an incentive for consumers to become more efficient, the price signal is what leads you to become more efficient. So the 2020 targets are having now an impact as well, but I think so far most of the difference is explained by the factors I just set out.
Got one or two more questions. Oh yes, the two ladies right here.
Oh, me.
Go ahead, and Gail. Gail, be follow up.
I was just going to ask about, in the U.S. we see all these kinds of manipulations being done to try to keep the GDP high. I presume there aren't too many other countries that can do this kind of thing, but it seems like in calibrating your models, the GDP you're looking at, to some extent, is not a real fixed number. It's a number that varies with the amount of debt and the amount of QE this and QE that, and low interest rates and whatever else they've come up with. And this has been happening now in different forms for several years. So even for calibrating models, the GDP number is not a fixed certain number. It's a number that they're working with.
I'm afraid I can't answer that question. Manipulation of numbers, I don't want to get into it. I'm sorry.
Our final question.
Yeah, you've talked about those consumption behavior differences between the US and Europe and their role in maybe, changing things. I've lived quite a bit in Europe, and I know, okay, it's good to be energy efficient, but we all know that the more energy efficient we become, the more money we'll have, the more I'll consume other things. I mean, if I have a fridge, an energy efficient fridge today, I'll buy a second one. If I have an energy efficient car, I'll travel, because I'll have more money. So what do you think the role of the rebound effect in this? And is this like a plausible condition for that?
Yeah, well, I mean, you know, I'm not a great expert on the academic literature on the rebound effect. Michael's probably more familiar with that than I am. But certainly, I mean, you know, so far it has held good. But I think, again, we're kind of reaching the point where there's, you know, more and more of everybody's disposable income, I think, is going to be going on energy in the future. And so you're going to be looking, you're going to be forced to retain those savings more and more over time, I think. But, you know, one of the other problems is there's more and more gadgets out there that use electricity. And that's been another massive driver of increased, certainly electricity consumption. You know, the fact that people have got, there seem to be televisions absolutely in every public space you go now, and whether it's airports or bars or pubs, you know, so there are screens everywhere, there are gadgets everywhere. I mean, the rebound effect does take its toll there, but I think there's still a huge amount of savings that can be made and that will have to be made in the future.
That wraps up our first afternoon session, and how about another round of applause for the two excellent speakers.